Okay, so there are some situations where forces must be resolved into perpendicular components that are not horizontal and vertical. So up until now, we've just been doing the x component and the y component, the horizontal and the vertical component. So for example, this one, a block of wood of mass 2 kilograms is placed on a slope which makes an angle of 30 degrees to the horizontal. So this angle here is 30 degrees. Find the component of weight parallel to the slope. So what it means by that is this component of the weight. So the weight, obviously we know the weight always acts vertically down. So that's our actual weight. But we want to find this, which I'll call WS for weight, component of the weight parallel to the slope of the S. So to find that, we can use a triangle. So you can see we've already sort of got two sides of a triangle there. We've got WS and W equals mg. And if we sort of connect up this line here, we've got a triangle where this is 30 degrees because this angle here would be 60 because that's 90 degrees, and we know the angles in a triangle add up to 180. So if I redraw that triangle there, got that's 90 degrees, that's WS, and that's our weight, mg. And we've got 30 degrees angle there. So if we use our SOHCAHTOA, so our trigonometry, then we can use sine. So sine theta equals opposite over hypotenuse. So the opposite, if we're looking at sine 30, and we look at that triangle, the opposite is WS, so the component of weight down the slope which we want to find, divided by the weight, which is mg. So the component of weight down the slope is going to be mg sine 30. And luckily, that's a cheat because that's always going to be that. So component of weight down the slope that will always be mg sine 30, sine theta, or sine, sorry, this one should be 30, but sine theta, and the theta is always the angle of the slope. So that's a really good way to sort of cheat. You don't have to do the triangle every time. You can just say that the component of the weight down the slope, WS, is mg sine theta. So as I said, good cheat. You can just always remember the component of the weight down the slope is mg sine theta, where theta is the angle of the slope. So to work that one out, we just need to put the numbers in. So the mass is 2 kilograms. G is obviously 9.8 times sine 30. And that comes to 9.8 newtons. For part B, it says calculate the acceleration of the block down the slope as the friction force acting on the block is 4 newtons. So for part B, what we have here is we have a 2 kilogram block. We now know the component of weight down the slope is 9.8 newtons. And we want to find, we know the frictional force is 4 newtons. We want to find the acceleration down the slope. So what we have here is an F equals ma equation. So F equals ma. So the unbalanced force is 9.8 minus 4 equals the mass, which is 2, times by the acceleration. And the acceleration comes to 2.9 meters per second squared. So luckily we can use that in other examples. We'll do the next example. So a box of mass 15 kilograms is placed on a slope which makes an angle of 30 degrees to the horizontal. So again, that's our angle. When the box is released, it accelerates down the slope at 2.5 meters per second squared. 2.5. And it's 15 kilograms. Calculate the force of friction acting on the box. So what we've got here is we've got 15 kilogram box. We've got a force down the slope, which is our component of weight down the slope. We've also got a force of friction. And we know that it's accelerating at 2.5 meters per second squared. So we're going to have to use F equals ma at some point, which is going to be the component of weight down the slope minus the friction equals the mass times the acceleration. So to find the component of weight down the slope, we now know that the component of the weight down the slope is mg sine theta. So it's 15 times 9.8 times sine 30, which comes to 73.5 newtons. So going back to our F equals ma, so we've got 73.5 minus the frictional force equals a mass, which is 15, times the acceleration, which is 2.5. So the frictional force will be 15 times 2.5, so 73.5 minus 15 times 2.5, which is 37.5. So the frictional force comes to 36 newtons.